So the first thing we're going to do for this topic is expanding, remembering how to expand different things. So the first type of expanding that you ever learnt about was the distributive law that looked like this, where you have a 2 out the front of a bracket and you multiply the 2 inside. So go 2 times A, you get 2A, and then plus 2 times 3 gives 6. Okay, that was the easy stuff that you learnt to do in year 7. Then you upgraded from that last year to learn when there was 2 brackets next to each other, and we learnt how to do FOIL. Remember that little acronym? FOIL, standing for first, outside, inside, last, when you have the 2 brackets next to each other. We want to focus as well on some shortcuts for perfect squares. So that's written in here, perfect squares and difference of 2 squares. You can always do these ones with FOIL, the longer way, if you're ever stuck, but a shortcut. If you have a perfect square, this is a perfect square here, A plus B in brackets all squared. That squared outside means that it's a perfect square. Okay? To the shortcut to expand that is whatever is in the first position in the bracket, you times it by itself. So A times A is A squared. Then you times the 2 things together, so A times B is AB, and you double it, which is how you get the 2AB. And then it is the last one times by itself, B times B makes B squared. Okay, so that is the shortcut method. For year 10, it's not going to be a big deal going back and using the full FOIL expansion, hopefully, although I know some of you are a lot more pressed for time in that last test for trigonometry, so we are trying to push that a little bit, trying to make sure that we can work to a time frame. But next year in particular, you will find people doing advanced and extension. Time in tests is precious. So if you can find shortcuts to do things, that is a bonus, okay? So at least try to have a go using the shortcut methods, and you could always be checking with your FOIL as a backup plan. The other one here, this is also a perfect square, it's just a subtraction. So you have A minus B in brackets all squared, so it's the same process, it's A times A makes A squared. Then you times the 2 things together, A times B, and doubled is going to make minus 2AB because of the minus sign. And then minus B times minus B makes a positive B squared. So that's your shortcut for perfect squares when you're subtracting. Then we have another one, and don't get this confused. This is not a perfect square. This is a difference of 2 squares. Okay? And it means that the 2 brackets that we have are the same, except that one is a plus and one is the minus. And the difference of 2 squares is actually what it expands out to give. If you do the full FOIL expansion, the 2 middle terms, the O and the I, will actually cancel out. So all you get is A times A, which is A squared, and the B times minus B, which is minus B squared. Middle 2 ones cancel out. So if you can identify that one, brackets the same, one's a plus, one's a minus, shortcut is just miss the middle 2 terms. Okay, so let's have a look at our examples. We want to expand the following. Start with some easy ones and work our way up. So the first one is a normal distributive law. I want to times the 3 into that bracket. So I'm going to go 3 times A is 3A. So some of you may still like to draw those little arcs in there to remind yourself what you're doing. Then I have a plus sign. 3 times 4 makes 12. Part B, same deal, just with a minus sign. Always be careful with minus signs. Minus 2 times 3m. Minus 2 times 3 makes minus 6, and we have the m. Minus 2 times minus 5 will become a plus 2 times 5 makes 10. Part C, still expanding. There are 2 brackets, but they're not directly next to each other, so you just have to do distributive law twice. So I'm going to do the 2x times into that first bracket. 2x times 3x makes 6. X times x makes x squared. Then 2x times minus 1 will make minus 2x. Now I'm going to expand the minus 4x into this second bracket. Remember to take that minus though, that's important to include. So minus 4x times x is minus 4x squared. And to minus 4x times 5, the minus times the plus will make a minus. 4 times 5 is 20, and we have an x. When you have a lot of terms like this, in particular, you want to check to see if there's any further simplifying that can be done. So I'm looking for like terms. Chloe, do you need that right now? Should you be doing this? Thank you. So I have x squareds. I have 6x squared minus 4x squared. So that's going to make 2x squared. And the minus 2x minus 20x minus 2 minus 20 more is going to make minus 22x. Always be careful of those minus signs. Part D. Looks more complicated because of the fraction, but it's not. I just need to times that 3 over 5 into each term. So 3 over 5 times 10. You can times that, if you're doing this in your head, you'd go 3 times 10 is 30, and divide that by 5 is 6 and x. Then the next one, 3 over 5 times 3. Doing the same process, 3 times 3 is 9, but 9 doesn't divide by 5 nicely, so I'm just going to leave that as an improper fraction. So plus 9 over 5. Okay, moving on. Question 2. You will see now that we have double brackets in here. So this is where you might want to write yourself a little note. You'll be wanting to remember to use FOIL. There's no shortcuts for these first couple. We want to do the full FOIL expansion. So we're going to do first thing times first thing. That's x times x makes x squared. O stands for outside, which means the two ones on the outside edge, which is the x times the minus 5, which is minus 5x. Then I stands for inside, the two middle ones. 2 times x is 2x. And L for last, the last thing in each bracket. 2 times minus 5 is negative 10. Most of the time you'll find that there's some simplifying here that can be done. So my two middle terms are like terms. I want to collect them up. So it's best if you try to put them in decreasing powers of x. So you want your x squared first, then x, then constant. So x squared minus 5x plus 2 makes minus 3x, and then minus 10 last on the end. Is this all very familiar from last year? Hopefully, yes, wonderful. Part B, same deal, we're going to do FOIL again. So first times first, 2a times 5a. 2 times 5 is 10. A times a makes a squared. Then outside, 2a times minus 4. 2 times minus 4 is minus 8. A and e sitting next to each other. Then the inside ones. 3e times 5a. 3 times 5 is a positive 15. And AE. If you keep them in alphabetical order, it'll be easier to see your like terms. And then last times last, 3 times minus 4 is minus 12. E times E makes E squared. So again, the two middle terms are like terms. Let's collect them up. 10a squared stays there. Minus 8 plus 15 is a positive 7ae. And then the minus 12e squared sitting on the end. Okay, so they were the normal FOIL ones. Question 3, did everyone get a chance to write those down? Sorry, I moved that pretty quick. You've all written that down? Yep. All right, so question 3, these ones are perfect squares. So you can see the bracket with the square there, perfect square. So let's try to use our short method. See if we can get used to that one. So the short method is you times the first thing by itself. So x times x makes x squared. Then you are going to times the x with the minus 3, and you're going to double that. So it's minus 3x, and double that would make minus 6x. And then you're going to times the minus 3 by itself. So minus 3 times minus 3 makes a plus 9. What do you think? Short method's okay? Yes?
Yep.
1 yes. As long as Charlie gets it, everyone's fine. Everyone's good? Okay, let's try it again. Short method for the second one. We're going to do 3x times 3x. 3 times 3 makes 9. X times x is x squared. Then we're going to times the two terms together. 3x times 5, which is 15x, and double it, makes 30x. And then finally, 5 times 5 for the last one is a positive 25. Any problems? Ah, okay, cool. Let's keep going. Too easy. Question 4 then. Expand the following. So you do see the two brackets there, so your brain's probably going, yep, FOIL, that's good. But these ones have the brackets the same, one's a plus, one's a minus. This is the difference of two squares. So you could do the full FOIL expansion, but those middle terms are going to cancel out. So the shortcut is just to do first times first, x times x is x squared, and last times last. Minus 3 times plus 3 is a minus 9. Does everyone understand what I mean by the middle terms cancelling out? I'm not going over that too quickly. That's fine with everybody? Yeah, do you want me to do it the long way? No, you happy? All right, let's do the next one, short method. Don't ever do the short method. Like, you have to know when it's a difference of two squares. If you ever try to do this difference of two squares and it's not a difference of two squares question, if you're missing those middle terms and you actually need them, you've got the question wrong. Okay, so you have to be certain you've identified it correctly. So the last one, first times first, 2x times 2x makes 4x squared. Then the middle ones will cancel, so we go last with last. 3 times minus 3 makes minus 9, and y times y is y squared. Okay? All right, so we are doing exercise 8A, those questions there. Try to use those short methods where you can.